Hi, and so the last section that we're going to work on in 3-3 is quartiles. So let's see what a quartile is. So quartiles are measures of location denoted Q1, Q2, and Q3, which divide a set of data into 4 groups with about 25% of the values in each group. Okay, what does that mean? Let's say this is all of my data, okay? And then right here, we'll say this is Q2, which is exactly the same as the median. All right, so what that means is that 50% of all of our information will lie to the left and 50% of our data will lie to the right. And then now that we have 50%, we can divide this again. And we can say, let's say this is Q1. That means that 25% of our data is less than Q1. And 25% of our data is between Q1 and Q2, right? That makes the 50% that's below Q1. I'm sorry, that's below Q2. And then we have Q3. Q3 is dividing this 50% into 25% and 25%. So here is my four slices, right? So here, 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 and we have 25% of our data right here, 25% of our data right here, 25% of our data here, and 25% of our data there, okay? And that's really what a quartile is. Think about it like a quarter, it's a fourth. A quarter is, 4 quarters make $1, so 1 quarter is 1/4 of $1. So quartiles are quarters. Okay, first quartile, exactly what I just said. Same value as P25. It separates the bottom 25% of the sorted data from the top 75. Remember we said Q1, this is 25%. If this is 25%, then the rest of this would be 75%. And so on. Just like I said with Q2. Q2, same as P50 and the same as the median. It separates the bottom 50% from the top 50%, okay? Just like we just talked about. And I don't think it's worth drawing another picture since I just drew it. And the third quartile, same as P75. It separates the bottom 75% of the sorted values from the top 25%. So if we go here, here's Q3, and basically what it's saying there is this, since this is 25%, then all of the rest of this is 75%. Okay, so really it's exactly what I said at the beginning, just separated down. So let's read the caution. Just as there is not universal agreement on a procedure for finding percentiles, there is not universal agreement on a single procedure for calculating quartiles, and different technologies often yield different results. Nothing for you to be concerned about. Our technology will yield the correct results. The lower quartile, so they're talking about the lower quartile as Q sub L, which is really the same as our Q sub 1, is the 25 percentile of the data set. The middle, which we're calling Q2, and also the median, is the median or the 50% for 50 percentile. And then the upper quartile, Q sub L, which we're calling Q3, is the 75 percentile. Okay. Okay, now we're going to talk about 5-number summary. So in this 5-number summary, we're going to use our, well, it'll probably say, we're going to use our minimum and our maximum, and then the 3 quartiles, Q1, Q2, Q3, that we just talked about. So let's use this information, and we want to find the 5-number summary. The 5-number summary is going to be min, Q1, Q2, which is the same as the median, and Q3, and max. Okay, so those are the 5 numbers that we need. Well, pretty easily, min equals 0.8, and max is 77.8. Okay, nothing to it. Now let's do our quartiles. Okay, so we have 50 pieces of data. Each row is 10, and we have 5 rows. So basically, we want to do 50 divided by 2, which is 25. So that means that because we have, if you remember from our last lecture, we really are trying to find the median, which is the middle, right? And 25 pieces of data are going to be below 50%, and 25 pieces of data are going to be above 50%. So this is 22 rows, 21, 22, 23, 24, 25. I'm going to put a little line here. And here's 20, 21, 22, 23, 24, 25. So our median, if you remember from median, is the mean or the average of those 2 values. So we add 13.7 plus 14.1, and we divide it by 2, which gives us 27.8 over 2, which is equal to 13.9. So our median equals 13.9. Okay. And I'm going to just erase all this. And let's say our median is going to be basically right here. We'll make this our median. So now we have our lower 50%. And that's what we're going to use to find Q1. And our lower 50%, so we're going to look for Q1 now. Let me write this equals Q2, Q sub 2. So Q1, we want to take our 25 and divide it by 2, and we get 12.5, which means that we have 12 on one side and 12 pieces of information on the other side. So here's 10, 11, 12. So this, I believe, will be Q1. Let's just check, make sure we have 12 pieces of data on the other side. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, perfect. So we have found Q1. Q1 is 7.9. Let me erase all these little dots here. So our Q1 is 7.9. And then our Q3, so our, how would I write that? I want to say that Q1 is 12 from the beginning and 12 from the median. And the same exact thing is going to be true of Q3. So actually I can say and Q3. And it's the same. It's going to be 12 from the median and 12 from the end this time. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This should be Q3. Let's just count. Well, there's 10 on the bottom, 11, 12. So that's perfect. So our Q3 is going to equal 21.5. And we've basically found everything. Another way to do this is instead of doing the how many numbers from everywhere it is, and this takes a little bit more time, but if you want, you're welcome to it. So I know I can cancel this whole row here with this whole row here, right? Because they have the same amount. And I'm trying to find the middle number, and I can say the same exact thing for this row and this row. So now all I really have to do is say, okay, well, this I can cancel with that, and this I can cancel with that, and this I can cancel with that, and this I can cancel with that. So now I found my median. It's the average of those two numbers, just like we said, okay? So again, we know it's between those two numbers right here, just like it was before. And now I can say, okay, well, I have 5 numbers here. So I can get rid of 5 numbers here because I'm just trying to find the middle, right? And then this can cancel with this, and this with this, this with this, this with this. I'm just taking one from each side until I get to the middle. And so now I have my Q1, and I can do the same exact thing. So I have 5. I'm gonna cross out these 5 and the last 5. 1, 2, 3, 4, 5. And then this with this, this with this. I'm sorry. Let's just actually let's do it this way. Here's 5 more. So 1, 2, 3, 4, 5. And then there we are, 21.5. So hopefully one of those methods you liked. You probably won't be doing this anyway. You'll be using StatCrunch, but you can still see that here is my Q1, Q2, and Q3. Okay. And let's just see, do we get the numbers right? Because here we did this in StatCrunch. And we're getting these numbers. So 0.8 and 7.9. 0.8, 7.9. 13.9, 21.5. 13.9, 21.5, and the maximum is 77.8. So we did the work. I'm sorry, we did the work. Where did it go? Okay, we did the work. And this is really what we're going to use. Obviously, we're going to use StatCrunch. So actually here, let's take a moment, bring up our StatCrunch. Bring up our homework assignment or our example assignments in this case. Get a little bigger. And here it says, basically all I have to do for this problem is find Q3. So I press on this, I open it in StatCrunch. Actually, I'm going to show you how to get all 5 numbers. Let's do that while we're at it. We're going to go to Stat, Summary, Stats, Columns. We're going to select column I'm sorry, column var 1, and that was unintentional. So we want Q1. Well, first thing we want is the min, and I'm holding down the control key. I want the min, then I want Q1. Notice there's no Q2. That's because that's the same as the median. Then we want Q3, and last we want the max. Okay, I'll get rid of our n. So there's our 5-number summary, just like we found. Compute, and all we really want for this problem is Q3, which is 5.7, and check answer. Okay, so this problem we're going to wait for, well, actually, we can do the beginning part, but I haven't talked about the box plot yet, so we'll do the 5-number summary right now because it's in perfect time. We just did one similar. So we have our column of data. We go to stat, summary stats column. We pick our column, and then we want, and I'm just going to put them in order. We want min, we want Q1, then we want median, then we want Q3, and then we want max. Compute. Okay, I'm gonna pop this over on that side so I can get my information. Let's see if I can make this any bigger. Oh, there it is. There, now you can see the numbers a little better. Okay, so our min is 0.59, 0.75 is Q1, 1.25 is the median or Q2, 1.37 Q3, and our maximum is 1.45. Check answer. And now we're going to see how to do this, but first we're going to go learn about it. So let's go back to our PowerPoint. Okay, so that's how you get the 5-number summary using StatCrunch. Now we want to talk about box plots. So a box plot, or a box and whisker diagram, so I'll start reading here, is a graph of a data set that consists of a line extending from the minimum value to the maximum value, and a box with line drawn at the first quartile, Q1, the median, and the third quartile, Q3. So the information we just got, now we're going to make a picture of it. So for the procedures for constructing a box plot. So we need to find the 5-number summary, which now we know how to do. Construct a line segment extending, so let's do it as we go, extending from the minimum value to the maximum value. So our minimum value before was 0.8, and our maximum value, I think it was 77.8 or 0.9. So find it. I think it's right here. Yes, max 77.8. Okay. And then we constructed a line segment extending from the minimum value to the maximum value. Now we're going to construct a box, which is the same as a rectangle, extending from Q1 to Q3. So Q1, let's go back and look. Which one was it? This one? No. It's here. Okay, so Q1 is 7.9. Q3 is 21.5. I'm just going to write this down so I don't forget. 7.9, and then I'll even write down our median, or Q2, 21.5. Okay. All right, so Q1 is 7.9. I don't know where that is, but now it's right here. And 21.5, okay. And it says make a box. So there's my box, okay. And draw a line in the box at the value Q2, which is the median. Our Q2 here, let me change color here. This right here, let's make that Q2. That's 13.9. And we're going to put a line there. So I've now made my box. Okay. We have something called the interquartile range, sometimes IQR, is the distance between the lower and the upper quartiles. Remember, the lower was Q1 and the upper was Q3. So this is Q1, Q3, and our IQR, interquartile range, is 21.5 minus 7.9, which is 13.6. Yes. So our interquartile range is 13.6. Okay, we'll have to remember that for a minute because we're going to need that. Why do we need that? So this looks really complicated, but I'm going to make it a little easier to understand. Let's just focus here first. This is our quartile 1. And this is our quartile 3. And this is our quartile 2. So this is Q1, Q2, and Q3. And right here is our inner quartile range, okay, which for us was 13.6. 13.6. Okay, now how do we find outliers? Outliers are 1.5 times our inner quartile range. So outliers, we're going to take our inner quartile range and we're going to multiply it by 1.5. And in our case, we have 13.6 times 1.5. And let me get my calculator. So 13.6 times 1.5. And that equals 20.4. So if I want to know if I have any outliers, my outliers would be more than our Q3 plus our IQR times 1.5. And also Q1 minus IQR times 1.5. So what does that mean for our numbers? Well, our Q1, let's write all our numbers down. Our Q1 was 7.9. Q2 was that. Okay, I'm sorry. I'm just writing all my numbers down here so I can remember it for the next thing when we're doing our calculations. Okay, so our Q3 for the last problem was 21.5. So so we have 21.5 plus IQR times 1.5 was 20.4, which is equal to 41.9. Okay, and our other outliers would be so basically here, our outliers are greater than 41.9. And if I take Q1, which is 7.9, and I subtract 20.4, which equals negative 12.5. If I have any values, so let me basically show you what this means. Okay, so let's draw this is our min, and this is our max. We have our Q1, Q2, Q3. Let's draw our box. And then anything greater than, let's say out here, is greater than Q3 plus IQR times 1.5. And over here, outside, actually, we wouldn't draw this line from min to max anymore if we want to put our outliers. We would say maybe from here to here, where this number here is the edge of my data that's not an outlier. Our outliers are going to go past this line. Okay, so for example, let's put our outliers. Well, I think we have to wait and do this for, let's see, maybe not. Hold on, let's go to the next slide. Yes, so this is the data, okay? What I'm going to do here is I'm going to grab, let me erase a bunch of stuff. Sorry about that, guys. This is just a little, this picture is a little complicated, and now I'm making it more complicated by putting all this stuff on it. So let's erase it. And let me copy all that stuff over here. And let's put it here. Okay, so here's my information. I have my let's call this Q1. We'll call this Q3, and this Q2. It doesn't actually have to be in the middle of the, let's put it over here just for the heck of it. Okay, so now here's my box plot. This is Q3. Okay, the number here is 7.9. This number, the next number is 13.9. And my next number is 21.5. Okay. And then I come out here, and let's say this is the end of the data that's not an outlier. My outliers are greater than 41.9. So I have 1, 2, 3, 4 outliers. And what we do is we can just put like dots or X's out here that say that we have some outliers out there, because this number right here is 41.9. I get it from here. And then we have nothing. we have no negative values. So right here, maybe this is negative 12.5, but we have no negative numbers. So we don't have to worry about that side. So all our outliers are sitting on the top end of our chart, of our box plot. Okay. And this is basically what it says. We're going to do this example in StatCrunch right now. All right. Oh, wait. So I have that, and then I already calculated. I already have StatCrunch open with my data right here, right? So I'm going to save this down here, and then I'm going to go to Graph, and I'm going to go to Boxplot. I'm going to select var1. I'm going to draw it horizontally because all of our plots on this Pearson are horizontal. And I think that's all I need to do. Compute. There is my box plot. Now, how do we match it? First, let me make this side a little bigger and that side a little smaller. Okay. It's not really very good. I need to see more. I need more. Okay. I think this will work. I need to see the bottom part of my graph. Okay, here we go. So the lowest number we have is right here. Actually, if I hold my mouse over the graph, I can see I have 11 values. My inner quartile range is 0.62. That's the distance between Q1 and Q3, or Q3 minus Q1 is 0.62. My lower limit is 0.59. So let's look at these graphs. Let me just open this bigger so that you guys can see it. Hold on. So that's a little too much. I think that's good. So here we see that, okay, here we see that this is 0.5 and this is 1. And how many segments do I have between them? I have 1, 2, 3, 4, 5. What does that mean? What it means is that I take 1 minus 0.5, which gives me 0.5, divided by 5, which gives me 0.1. So each one of these dots, each one of these lines here, so this would be, I'm not going to put the 0 because I don't have space, 0.6, 0.7, 0.8, 0.9, and then 1.0. Well, if our lowest value is at 0.59, yeah, that works. Actually, all of them look like they're beginning in the same place. So that's not going to give me any good information. So they all look the same here. The next one we have is 0.75. That's the beginning of this graph. So 0.75, well, that would be about right here. So we know it's not A. Okay. I think I'm going to have to open this up bigger. Okay, I'm sorry, guys. Let me erase what I have here. And so we know it's not A, right? B. So it starts in the same place. We know that this is 0.6, 0.7, 0.8. That's a little close to 0.7 that I want. I don't think it's B. Let's look at D. 0.6, 0.7, 0.8. That does look like it starts around 7.5, which is where it's supposed to start, or 0.75, which is where it's supposed to start. So D is a definite possibility. Let's see where Q2 is. Q2 is 1.25. Here's 1. Here's 1, 1.1. I don't know if you can see where my mouse is. 1.1, 1.2, 1.3. So that's looking pretty good, right? Because we want the median. We want the median to be 1.25, and it looks like that's what it is. We want Q3 to be 1.37. Okay, so 1.1, 2, 3, 4. D looks very good. And it's going to end there. The maximum value is 1.45. That looks good as well. I like D so far. And we can see right away that our Q2 here, or our median, is 1.25, which is not C, because there's 1, 1.1, 1.2. So it's not it. We can see it's definitely D. And let's check our answer. Okay, so hopefully that helped. Let's go back to the rest of our PowerPoint. We're almost done. Erase that stuff. Okay. And this is, I took a picture with everything showing for this one. And you can see here on different data, we didn't use this data. We can though. Actually, we will. We're going to use this data and I'll show you how to get this. And you can see here, if you look really close, it says we have 4 outliers. There's 1 underneath and there's 3 more here. That comes from our Verizon data. Now I'm going to show you how we get this data and how we find these outliers, okay? First, what I'm going to do is I am going to go back to StatCrunch. Okay. Oh, I actually have the Verizon data loaded here. I thought I had to reload it. So we have the Verizon data loaded here. And let me see. So we want to show how to get the outliers, right? So we're going to start off by finding our summary stats. Column is Verizon. And we want the minimum. We want Q1, the median, Q3, and the max. Okay. So we're going to start with this. And now what we're going to do is we're going to use some of those equations that we had earlier. So for example, we know that we have our Q3 and we know that we have our Q1, and our inner quartile range we found before, but we can subtract it again. It was, let's see, 13.6, okay? And then we multiplied our IQR by 1.5. And I don't remember what we got, so I'll do it again. Okay, this is 20.4. And again, hopefully you remember, we add Q3 plus, I'm just going to say this IQR times 1.5 is 20.4, which is equal to 41.9. And also we take Q1 and we subtract 20.4, which is going to be equal to 12.5, negative 12.5. I believe that's our numbers. I guess I should do it on my calculator just to make sure. Yes. Okay. So now we have our box plot here. Let me see. Okay. Perfect. Okay, so now, well, we know we don't have anything lower. We don't have anything lower than our 0.8. So we don't have to worry about an outlier to the left of our box plot, right? So but we might have values bigger than 41.9. So let's see if we do. I sure do. I have 1, 2, here, let me circle them. I have, or I'll just put a check mark, 1, 2, 3, 4. So on this graph, if this is 21.5, I'm sorry it takes me so long to get between my mouse and my pen, but it does. All right. All right, so there's our, well, we could probably see all our numbers without worrying about that. Okay. So we have our Q3 plus our interquartile range times 1.5 is 41.9. And let's say that 41.9 is somewhere around, let's see, it's right here, 41.9. Now I notice I have these 4 numbers that are past that. So those are our outliers. So we'll have an outlier at, let's call this 43, 55, probably not going for, it's okay, 55.6, 71.3, and our 77.8. So those are our 4 outliers. Now, if we want to look at this on our graph, let's do a box plot. So let's go back to StatCrunch. We'll open that up. Let me erase everything. All right. So here's our 5-point summary data graph, our box plot. We're going to select the column. We're going to draw it horizontally. And that's pretty much it. Compute. There we have it. Now notice there are 4 outliers. And if I hover over them. Well, first I should be able to get the numbers. So there's my 43, which is what we said. 55.6, 71.3, and our 77.8. This line is now going to our upper limit. Remember, our upper limit was 40 point something, but we only have one number. So here's our 43. This number, 38.5, is the biggest number underneath our outliers. So that's where this part of the box plot is going. If you notice, right, and I don't think I can do this at the same, no, it won't work that way. Okay, that's okay. I'll just show you. So I just have to get my mouse right on it. And we can see, let me do this. Okay, we can, no, it doesn't want to let me. I'll just hold it there. And we can see that the upper limit is 38.5. And then all the rest of our Q1, Q2, Q3 don't change. Our lower limit, 0.8, is still 0.8 because that's the smallest number. And we've found our inner quartile region, which is 13.6, which is what we found earlier. So we can get all this information still through StatCrunch. Okay, hopefully that all made sense. And I don't think I'll just close it down like this. All right, so that takes care of this slide. And I think we're really pretty much, we're getting to the end. So here's the steps, box plot. Find the quartiles, Q1, Q2, Q3. Find the inner quartile range, which is Q3 minus Q1, and multiply that value by 1.5. So in a modified box plot, a data value is an outlier if it is above Q3 by an amount greater than 1.5 times our IQR or below Q1 by an amount 1.5 times IQR. So basically, it's just really talking about, we have our, here's our Q1, here's our Q2. Let's call this our Q3. Then we have our line goes to the beginning of our IQR times 1.5 plus Q3. And the lower end either goes to the minimum, or it could go just to the max or max. If the max is the max and we don't have anything bigger than that, we have no outliers. And then this same thing is true here. This is Q1 minus the inner quartile range times 1.5. And that's what this line is. And it's also the minimum if we have nothing smaller than that, okay? That's basically all we have here. And then, let's see what our next slide says. Oh, our next slide is, that's basically it for how you make a box plot. And you won't be making them really by actually plotting them. You'll use StatCrunch, but you at least understand what you're getting. All right, and then we want to talk a little, just for one slide, about skewness. So a box plot can often be used to identify skewness. If you remember, skewness is how much the graph, if you were to graph it, or the curve, it's like if we had something like this is skewed to the left because we have a longer tail on the left. Or this is skewed to the right because we have a longer tail on the right. So we have more data on the right here. We have more data on the top one on the left. A distribution of data is skewed if it is not symmetric and extends more to one side than to the other, which is exactly what I showed you a picture of here. So that gives us some information, okay? And we can see it, it shows up in our picture. And here is elements of a box plot. I know we've been through this a million times, but I'll read it to you one more time. So number one, a rectangle or the box is drawn with the ends, sometimes called the hinges, drawn at the lower and upper quartiles. They're calling it QL and QU. We're calling it Q1 and Q3. The median of the data is shown in the box, usually by a line. The median is Q2. Okay. The points at distances 1.5 times IQR from each hinge mark, the inner fences, is the data set. Or the lines, sometimes we call them the whiskers, are drawn from each hinge to the most extreme measurement inside the inner fence. So we have a lower inner fence, just like I just said. So Q1 minus the 1.5 IQR, and the upper is Q3 plus 1.5 times IQR. Okay. A second pair of fences, the outer fences, appear at a distance of 3 times IQR from the hinges. We haven't really dealt with that. It's just another, they're even more of an outlier, right? Because they're further away from the rest of the data. One symbol, for example, this asterisk, is used to represent the measurements falling between the inner and outer fences. And another, 0, is used to represent measurements that lie beyond the outer fences. Thus, the outer fences are not shown unless one or more measurement lies beyond them. So if we know that where there are 1.5 times IQR is, then we multiply it times 3 and we have another set of data. We may have more data in there. If they fall outside of this 3 times IQR, basically this is saying that we don't even show it, okay? It's just too far out. The symbols used to represent the median and the extreme data points, those beyond the fences, will vary with the software you use. Ours were dots and used to construct the box plot. You may use your own symbol if you are constructing a box plot by hand. You should consult the program's documentation to determine exactly what symbols are used. We saw, I think it was, I don't remember where it was, here, that they're dots, okay? Aids to the interpretation. Now we're going to look at how you interpret the box plots. The line or the median inside the box represents the center of the distribution of data, right? That's what the median is. Examine the length of the box. The IQR is the measure. So for example, let me draw it here. So here's my box. Let's say this is our line, that's the median, and this is Q2, or the median. Examine the length of the box. That means they're talking about from here to here. What do we call that? We call that our IQR. And it's a measure of the sample's variability. And it's especially useful for comparing two samples. Why does it measure its variability? Because the wider it is, the more the more the data is spread out. If IQR was really small, then most of the data would be in a very small, wouldn't be separated by very many numbers. Like the difference between, let's say our IQR is 50. So between Q1 and Q3, there's 50, for example, let me see if I do better with an example. So let's say this is 15 and this is 65. Those are separated by 50 points. That means the data is spread out a lot more than if I were to change this to 3 and 8. Now, all of our data, or most of our data, actually, if this is Q1 and this is Q3, then 50% of our data falls between 3 and 8. Whereas the other one, 50% of our data falls between, what did I say, 15 and 65. So that's a big difference. And why do I say that? Because this is Q1 and this is Q3. And if you look at it, on just a line, Q1, 25% of the data falls below it. Q3, 25% of the data falls above it. That means 50% is in that region, or our IQR. Okay. Visually compare the length of the whiskers. If one is clearly longer, the distribution of the data is probably skewed in the direction of the longer whisker. So the longer the whisker is, we're skewed in that direction. Analyze any measurements that lie beyond the fences. Less than 5% should fall beyond the inner fences, even for very skewed distributions. Measurements beyond the outer fences are probably outliers, and one of the following explanations. Okay, so we have our box plot, and then we have these outliers. So why do we have outliers? Either the measurement, we may have made a mistake when we measured something. It may have been observed, recorded, or entered into the computer incorrectly, right? That's always a possibility if we have something that just doesn't make sense, that it's in our data set. It may not be. You may want to look again and see if there's a mistake. B, the measurement belongs to a population different from the population that the rest of the sample was drawn from. So let's say I was measuring Labrador retrievers. I wanted to have I wanted to know what the smallest, what the biggest, how much they vary, and somehow a poodle got in. So it would skew the data, right? And so that's what this B is saying. It may have just kind of gotten in there by accident. Or the measurement could be correct and from the same population as the rest of the sample. Generally, we accept this explanation only after carefully ruling out all others. So if you see outliers that don't make sense, you want to look at the values and see where they came from and see if they came from a viable source. If you find an error in how you measured it, or you find that it wasn't even supposed to be in our sample, those are two possibilities. You always want to look for that first. If you don't see any problems, then you just have some outliers. You just have a really big, maybe you have a really big dog. So that's really all that's saying. And I think that's enough said about box plots. And I'm going to complete this lecture now. Thank you for watching, and hopefully you learned something. All right. Have a good one.